Alright, so here we have the quadratic formula, and what's actually cool is that any equation can be solved using the quadratic formula. So the quadratic formula, whenever it's written in ax squared plus bx plus c equals 0, it has solutions x equals negative b plus or minus b squared minus 4ac all over 2a. So we're going to go ahead and start by solving one using the quadratic formula. So first thing you want to do is make sure it's in that format, ax squared plus bx plus c, and it is. So in this case, a is equal to 3, b is equal to 16, and then c is equal to 5. So we're going to go ahead and plug it in. So negative 16 plus or minus 16 squared minus 4 times 3 times 5 all over 2 times 3. So what I like to do is I like to plug in everything that's inside the radical into my calculator, and that gives me 196. And 196 is actually, the square root of 196 is actually 14. So that's going to be negative 16 plus or minus 14 all over 6. Okay, then after that, we're going to go ahead and split it up into two things, one with the negative and one with the minus. So negative 16 plus 14 all over 6, and then negative 16 minus 14 all over 6. Then for these ones, you always want to simplify the numerator first, and then simplify the fraction. So this is going to be negative 2 over 6, and that's going to simplify to 1/3. Okay, then over here we get negative 30 over 6, and that's going to simplify to negative 5. And so our two answers are going to be these. All right, so moving on to another example, we have 2r squared minus 4r equals 3. So notice it's not in that format. That's ax squared plus bx plus c equals 0. So it's not equal to 0, so we're going to have to go ahead and subtract 3 to both sides. And we could get 2r squared minus 4r minus 3 equals 0. So now we know a is equal to 2, b is equal to negative 4, and c is equal to negative 3. And then we're going to go ahead and plug it in. So we're going to get negative 4 plus or minus negative 4 squared. So make sure to put parentheses around those negatives. 4 times 2 times negative 3, and then all over 2 times 2. So the negative and the negative become positive, so plus or minus. And then inside the parentheses, we're going to simplify. We're going to get 40, so square root of 40 over 4. And then afterwards, the square root of 40, we're going to go ahead and do that on the side and simplify that. So that's going to give you 4 times 10, 2 and 2, 5 and 2. And so here's a pair, and this is what's left over. So remember, what has a pair is on the outside, and what's left over is on the inside. So this is what we get. So plus or minus 2 square root of 10, 4 over 4. All right, so now, because if you see all the numbers on the outside, 4, 2, and 4, they're all divisible by 2. So I could simplify them all by 2. So that's going to be 2 plus or minus 1 square root of 10 over 2. Now, they don't have a number that I could divide all three of them, so that's as far as you could simplify them, and you cannot simplify that 2 and that 2. So it's all three of them or nothing. All right, the next thing we're going to learn is inside the quadratic formula, we have the radicand, which is what's inside the radical, b squared minus 4ac. That's called a discriminant. And this tells us the number of solutions and the type. So here's this chart here, where depending on the value of the discriminant, it'll tell us the number and type of solutions and then the graph, and I'll go ahead and tell you the x-intercepts too. So if the value is positive, we have two real solutions. They're sometimes rational or irrational. And then if you look at the graph, there are two x-intercepts. All right, if the value is equal to 0, we have one real solution. And if we look at the graph, there's one x-intercept. And if the value of the discriminant is negative, we have two imaginary solutions, which means we have no real solutions and no x-intercepts. All right, so let's go ahead and use the discriminant. So to find the number of solutions, the number of x-intercepts, and then the type of solutions. So first we have to make sure it's in the format again, ax squared plus bx plus c equals 0. And it is. And so a is equal to 1, b is equal to 2, and c is equal to 1. We're going to go ahead and plug it into b squared minus 4ac. So that's going to be 2 squared minus 4 times 1 times 1. So that gives us 4 minus 4, which equals 0. So this is the value of the discriminant. So let's go back up here. So the value was 0, so that means one real solution and one x-intercept. All right, so that would be our answer here. All right, so the next one is actually not in the format that we need it to be. So we're going to go ahead and fix that. I'm going to go ahead and subtract 4 to both sides, and we get 2x squared minus 7x minus 4 equals 0. So a is equal to 2, b is equal to negative 7, c is equal to negative 4. We're going to plug it into our discriminant to find the value. And so that's going to give us 81. I plug that into my calculator. So it's a positive. The value is a positive, so then therefore it means two real solutions and two x-intercepts. And that would be our answer. All right, so the last thing we're going to cover is a word problem. So a local university has a walkway, and students often, probably, they walk this way, right? And so what happens is some students like to cut the grass or cut through the grass, and they'll walk this way. And so that forms a triangle and a right triangle. And so we could use the Pythagorean theorem to have an equation for this. So x squared, so by the way, the Pythagorean theorem is a squared plus b squared equals c squared. And I went ahead and labeled what a, b, and c are. Remember, c is the hypotenuse, which is your longest side. So this would be x squared plus x plus 20 squared equals 50 squared. And we're going to go ahead and simplify. So this right here, we could either use the box or the FOIL or distribute in whatever you want. I'm going to go ahead and just do the box. All right, and I'm going to go ahead and do that down here on this side. So you're going to multiply across. So x squared plus 20x, 20x, 400. So this gives you x squared plus 40x plus 400. So we're going to go ahead and substitute that in. And that's equal to 2,500. So we're going to have to use the quadratic formula. That's what we learned here. So I'm going to go ahead and subtract. And then we could add these two together. So we get 2x squared plus 40x minus 2100. And so a is equal to 2, b is equal to 40, and c is equal to 2100. We're going to go ahead and plug that into the quadratic formula. All right, so here is the quadratic formula. So negative 40 plus or minus 40 squared minus 4 times 2 times 2,100 all over 2 times 2. And then again, I'm going to go ahead and plug what's inside the radical into my calculator. All right, and then I get 18,400 all over 4. And in this case, we're going to take the square root of that and see if we get a perfect square. Okay, and we don't, so since we're dealing with a word problem here, I'm going to convert it into a decimal. So negative 40 plus or minus 135 point, let's just use 2 decimal places, so 65 all over 4. And then remember, we're going to break this up into 2. So negative 40 plus 135, 65 over 4. And then x is equal to negative 40 minus 135, 65 over 4. This one, I could already tell it's going to give me a negative value, and we can't have a negative distance. So this one will not be a solution. So let's go ahead and focus on this one. I went ahead and plugged this all into my calculator, and I got 23.91. So we could say it's approximately 24 feet. And so let's go back up. So remember, we're solving for x. So x was a, and this one is saying, the question is saying, how much do we save by cutting across? So I'm going to redraw this picture down here with the values that we actually have. So 24 was this was 50, and this is going to be 24 plus 20. So when we add this together, we get 44. Okay, so if a student is walking this way, he is walking 68 feet. And so by cutting across and only walking 50 feet, they are saving 18 feet.